Numbers. We see them everywhere, every single day. On price tags, on clocks, on our phones. We think we know them, right? But what if I told you that every number has a secret identity? A hidden life that's way more complex and flexible than we usually give it credit for. So let's dive in and uncover a number's secret identity. Okay, let's start with this refrigerator. It costs $2,698. Seems simple, right? It's just a straightforward number. We see it, we get it, and we move on. But for our little investigation today, this simple price tag, well, this is where it all begins.
So that gets us to the big question. What does that number really mean? I mean, is it just a collection of digits sitting there? Or is it something more? Can we look at it from different angles and maybe discover something new? And the answer to that is a huge, resounding yes.
See, we're all kind of trained to think of numbers as these fixed, rigid things. But the truth is, they have this amazing hidden flexibility. And understanding that flexibility, it's like having a secret decoder ring for the whole world of math. It lets us see these same exact quantity in so many different and really useful ways. So, how do we start cracking this code? Well, our first tool is something called place value, and more specifically, the art of renaming. Trust me, this is the key that unlocks all of a number's secret identities. Renaming is such a simple but really powerful idea. Basically, it's about writing a number in a different way without changing its actual value. Take 3,000, for example. We can also say that same amount is 30 hundreds. The value hasn't changed one bit, but the way we describe it has. Getting this idea is the first big step. This chart is a great way to see renaming in action. Look at that top row. We've got 6,000 shown as a 6 in the thousands place. Simple enough. But now check out the second row. If we kind of trade or rename those 6,000s into hundreds, what do we get? We get 60 hundreds. And if we go one step further, like in that third row, we can rename those as 600 tens. It's the exact same value, just wearing a different hat. Okay, let's try it with a trickier number, 1,234. In that top row, it's all broken down nice and neat. But in the second row, you see how we've renamed the 1,000 and the 200s together into 1,200s? And then in the third row, we've grouped almost everything to make 12 3010s. Being able to see a number like this is what turns you into a real number detective. And look, this isn't just some clever party trick. It's a core concept in math. Just like the quote says, you have to be flexible. The ability to see 1,200 as not just 1,000 and 200s, but also as 1,200s is an incredibly powerful skill that opens up totally new ways to solve problems. So, once we understand that numbers can be renamed, we can start to recognize their many disguises. And you should really think of these as the different outfits a number can wear, depending on the occasion. First up is the disguise we see every single day. Standard form. This is just the number written out with digits. It's the most common way we see numbers because, well, it's clean, it's efficient, and pretty much everyone understands it. 3, 4, 5, 6, we know it instantly. Then we have what I like to call the reveal all disguise, expanded form. This is where the number basically takes itself apart and shows you the value of each and every piece. So 3,456 becomes 3,000 plus 400 plus 50 plus 6. It's kind of like looking at the blueprints of the number and seeing exactly how it's built. And finally, we have the number's most formal disguise, word form. And just like the name says, this is when we write the number out completely using words. You don't see it as often, but it's used in some really specific situations where you need absolute clarity. And here is a perfect real-world example of why this matters. On a check, you write the amount in both standard form and word form. But why? Well, think about it. It's a lot harder for someone to illegally change 143 than it is to just change the digits 143. So in this case, this particular disguise is actually a form of security. And this brings us to a really crucial point. These different forms, these disguises, they aren't just for show. Each representation has a purpose. Each one is a tool designed for a very specific job, helping us see a different side of the number's story. Just look at this slide. It shows the number 1240 in 6 totally different ways. We've got base 10 box, an equation, a place value chart, the whole shebang. They all represent the exact same value, but each one is a tool that's really good at telling a different part of that number's story. Okay, so I've got a question for you. Looking at all these different ways to show 1240, which one do you think does the best job of proving that it's an even number? Go ahead, take a second and look. If you picked representation 2, you are spot on. And here's why. The very definition of an even number is a number that can be split into two equal whole number groups. And 620 plus 620 shows that perfectly. It's not just telling you it's even, it's showing you the proof. All right, let's try another one. Same number, 1240. Which of these representations gives you the quickest, most gut-feeling sense that 1240 is just a little bit bigger than 1,000? For this job, the base 10 blocks in representation 1 are the absolute star. That giant 1,000 cube just dominates the picture, and you can instantly see that the other little bits, the hundreds and tens, are pretty small in comparison. It gives you an immediate visual feel for the number size. All right, you've learned the techniques, you can rename numbers, you can spot all the disguises, and you know that every representation has a purpose. Now it's time to put it all together and solve a case. The mystery number case. Here are the facts. We've got 3 clues about a mystery 4-digit number, and we've got an empty place value chart. Our job is to use our new detective skills to figure out this number's identity and fill in that chart. Okay, let's break down these clues one by one. Clue 1 is pretty straightforward. The number is between 4,000 and 6,000. So we know the thousands digit has to be a 4 or a 5. Easy. Now, clue 2 tests our renaming skills. To be written as a whole number of tens, the ones digit has to be a 0. But since it can't be written as a whole number of hundreds, we know the tens digit can't be a 0. Interesting. And finally, clue 3 brings an expanded form. If it only has 2 parts, that means our number can only have 2 non-zero digits. So let's put it all together. We need a 4 or 5 in the thousands place, a 0 in the ones place, something that's not 0 in the tens place, and only 2 digits that aren't 0 in the whole number. The answer has to be 4010. It's between 4,000 and 6,000. You can write it as 410s, but not as a whole number of hundreds, and its expanded form is just 2 parts, 4,000 plus 10. Case closed. So the big takeaway here is that numbers are not just these static symbols on a page. They're dynamic, they're flexible, they're ideas with their own stories to tell. So the next time you see a number, don't just read it. Challenge yourself a little. Try to find its secret identity. What hidden story will you find?